Okay, good. Yeah, good morning, everyone. Welcome to the third Learning at Lambert Labs session. And yeah, today's presenter is me. So I'll just kick off. The topic I want to talk about today is the Linux file system. And I know that sounds like why would I choose such a kind of seemingly boring topic? But actually, I think it's rather interesting because you can learn a lot about how the hardware integrates with the software, and I think it's also quite useful for many other applications as developers. But I kind of outline that in this slide, and yeah, so certainly when I was learning to program, I did a lot on macOS and Windows. I didn't really use that much Linux. So coming to it and seeing the file system was a bit of a, to me at first it was a bit of a confusing mess. So yeah, I hope this helps to demystify a little bit. I think it's also useful when you're trying to set up a new machine, if it's running Linux or Mac, because of the similarities between the two. I think it's very useful to know where you can expect software packages to be, or where configuration files will be, or where log files will be. And I've kind of mentioned it before just now about the similarities with Mac OS X. I put that with an asterisk because this is all to do with implementing a POSIX standard. Mac OS X, since Snow Leopard, implements that standard fully. Linux does it. I think most Linux OSs do it partially. So anything I really say about Linux will be partially applied to Mac. And I know that a lot of us use Mac. So yeah, I hope that this, you can still gain something from this if you use a Mac. And yeah, hopefully you find it interesting. But yeah, I think to be a bit more specific about what do I mean, this is what I mean by the Linux file system. I don't mean how it's formatted, whether it's X4 or exFAT file systems. I'm more talking about actually the layout. And yeah, so we have, as you know, a // that's the root of the file system. Any users that live in home. So for instance, my user called Aaron, that lives in home, and all these other directories hang off the root of the file system. And I think we'll probably dive into a few of them. Probably the most important one to know about is this boot directory. And I think you can probably tell from the name what that's used for. Essentially, the boot directory is everything that is needed by the system to actually boot the OS, or kind of more precisely, orchestrate the booting of the OS. And I'll kind of show you what that looks like. So you can see here that I'm the root user. And if I go ls, you can see that I'm in the root of the file system. And we have boots here. So cd boot, ls. And yeah, we can see here that I've got this image here. What's this? This is a RAM disk image. This is loaded by the bootloader before you load the kernel. And what it does is that it looks at your system and it's trying to do hardware detection, and it loads modules based upon that. And I'll show you this in a diagram later. But that's quite important to do that. That's that. The other bit, the kind of complementary bit to that is the actual kernel itself. That's in this file here, vm-linux. And yeah, that's essentially just all the kernel modules, but they're compressed. The reason why they're compressed is because in early systems, access to the hard drive when you were booting was quite limited. So as the kernel got larger and larger and larger, and more modules were added, it didn't become practical. So there was a bit of a trade-off. The penalty for, compressing this when it's loaded, decompressing it when it's loaded into RAM is more than offset by the fact that we've now got, in theory, a kernel that we load that's a lot smaller because it's compressed. Yeah. There's a couple of other things of interest here. There's something called a system map, which is a symbol table for the kernel, or the compiler for the kernel. And we can have a look at what that looks like. Yeah, cool. So we have here this hex number, we have some kind of code here, and then we have this name. It's very simple, really. When you're compiling a C file, the compiler has to know, okay, I've got this variable X. I want to know what type it is and where it's stored. And that's what the symbol table is for. I can show you that more specifically. If I go to VS Code, I just wrote up this C file, and if I were to compile this, it would throw an error, because it's because the symbol table is, looking at all the symbols. I've got food, which is a function, integer, and then I've got A, B, Z, and Y, which are all ints. And it's basically saying, well, here I've got this unary operation, and I'm applying it to a variable called A. And so the compiler's like, okay, what's A? They say, oh, it's an integer. But the unary operation is not valid on an integer, and so hence there is an error. And that's why you get that. That's why you get that error if I were to compile this or try to. It's because of the symbol table. So that's that. Yeah. And yeah, finally, there's also this Grub, which the details of that are a bit complicated. I'm not entirely sure of the full inner workings of it, but it's a bootloader. That is initially what is orchestrating the loading of the RAM disk image and the kernel. And I think best to show that visually. This is a very typical booting process. When you start the computer, the BIOS or the UEFI chip runs what's called like a post test, which is it just powers on all your devices on your computer and checks that they power on correctly. If it does that, then eventually we want to load the bootloader, which, as we just saw, was called Grub. And this will do two things. It will either load the kernel, or it will load this RAM disk image, which mounts a tiny little file system, which does that hardware detection and the kernel module loading, as I described earlier. Once you've done that, then you can mount the real file system and get on with booting the rest of the OS. So you can see that that boot directory is probably the most important of all the directories. But you might be asking, why even bother separating it into boot? Like, in theory, would it not be possible to just, why have a separate partition? Why put it into a different directory if it's so crucial? And I think that's a very good point. I did a fair bit of reading around it. It doesn't really seem like there's a real hard reason why, but the soft reasons are that if you have a very exotic file system, for instance, if it's encrypted, it's helpful to have a tiny little partition that has the bootloader and all the other necessary things for booting the system into a tiny little 200 megabyte partition, which is unencrypted, and the rest of the file system can be encrypted. And that way you can still load your file system relatively easily, but you still have the benefits of encryption. That might be one use case. I guess for most end users, you could consider it legacy, and for that reason, there's no real need for you to touch it as a developer, unless you really know what you're doing, which certainly I don't. I wouldn't feel comfortable on my work machine messing around in here unless I really have to. Yeah, hopefully that kind of explains that really crucial part of the file system. I think I can move on to the more sort of parts that are probably a bit more familiar to you. The next one I want to explore is the bin directory, and that is this one. And you can see that it points to this Unix system resource /bin directory, and that's called a symlink. So essentially the bin, it contains a lot of binaries, but it doesn't really. It's more of it more just points to the actual directory that does it. And that's just because Ubuntu have essentially cleaned up the file system a little bit. But, what can you expect to find in bin? You can expect to, or user bin, you can expect to find kind of system executables like echo, GCC, that kind of thing. In fact, actually, if I look into bin, we'll see ls block. That's very useful. Lists all the partitions. And you can see here that that's my boot partition that I was talking about earlier, and that's my root partition, or the rest of the file system. And these are the partitions on my hard drive. That's the name of my hard drive right there. But like this kind of system executable is located in bin. Okay. Then you might ask, well, you may have already seen user bin or sbin or user sbin and user local bin, and you might be thinking, well, hang on, it just keeps going and going. What's the, what do those all mean? And yeah, this is where it gets the line gets a little bit blurry. From my understanding, you can consider user sbin and just sbin kind of basically the same thing. We basically do the same thing. You've got like these executables that really only have semantic meaning if they're run by a system administrator. And likewise for bin, that can be run by any user. But really, it's kind of similar to user bin. But yeah, I guess the old definition was that bin and sbin contained things that were needed for what could be used for booting, whereas you didn't typically do that in user sbin and user bin. But now that's no longer the case, and in fact, hence why they put that symlink in that you can consider them basically equivalent. The one kind of differentiation is we've got this local sbin. So I think if we go to so we've got like this user local bin, and I think that's kind of executables that have been manually installed. They're not really part of the distribution. So that's kind of a more hard distinction than between user sbin and sbin, for example. Okay, so hopefully that helps. We'll move on to dev now. And you may have heard in Linux that everything is treated as a file. Every device is treated as every kind of device or pseudo device is treated as a file, and that's kind of because of the Posix standard. It's trying to implement Unix-like behavior. And so what does that mean in practice? If we go to dev, and you'll see all of my devices here. So, I've got pseudo devices. I've got this random number generator here, urandom. I've got null, which is simply a device which you treat as a bit bucket. You send stuff to dev null when you just don't care about the output. You may have seen that in bash scripts. What else? Oh, we have here the streams, standard in, standard out, standard error. And yeah, these are, pretty useful. They're tied to a process, and yeah, I guess they're treated as devices more sort of out of the convenience to the processors on this machine. It kind of makes it more accessible. But yeah, in fact, actually, I can kind of demo this. If I were to go to to home. And if I were to type in lsdev, and I want to point that to just a file. So I want to basically list everything here and write it to this dev list file. That's fine. And it's just got all of my devices listed. If I then plug in, and I've got in my hand here this kind of USB SD card reader, and I'll just plug it into a USB slot on my computer, and I could just see it light up. You know, I've essentially plugged in a new device, so I'd expect something to appear in that dev directory, and I can see it if I go lsdev, and I'll make a new one. I'll say new dev list. And to compare the differences, I can use a diff, lines, -y, new dev list, and the old dev list. Right, cool. So yeah, we've got a difference here just because I plugged that in, and yeah, it reads it as a an SDA device. So yeah, it's clearly ready for me to mount a new hard drive, which makes sense. It's an SD card reader. Okay, so I'll just plug that out. And then if I were to do that again, I'd actually see no difference because I've now unplugged it. Cool. Next one, Etsy or etc. Really simple. This is just configuration files or kind of really typical key value pairs that you might find in the system. They're just kind of like very useful configuration that's system wide. So for instance, we have the SSH file here, which I'm not going to cat on the screen, but this is kind of system wide SSH config. Any kind of user specific SSH config, well, typically we have that in this hidden directory in your home directory. But this Etsy SSH is system wide. We also have MIME types, which are just different types of file. So any process can look up what type of files the system can read. There's also other things like mtab. It lists all the currently mounted file systems. Kind of a bit, you could argue that could go somewhere else. I'm not really too sure. I think because it's treated as static, it can probably go into the configuration folder. Yeah. var is an interesting one. Var is a bit different. It's not static. Everything in there is really expected to grow. And what does that mean? Well, you may have seen when you're working with Docker images that typically the log files are all stored in var. They're all expected to grow. If something's gone wrong in your Docker image, usually the first thing you do is look into var and look into logs. Is there anything there that kind of indicates to you that there's a problem? But it might not just be used for logging. You could also use it to, for instance, if you have a print job and it's queued, that would be stored in var because it's expected that an application will execute it and then delete it later. And you can see that if we go to var, we can see here we have the spool. Go to spool, and yeah, we have all sorts in here. We have cron jobs that are waiting to be executed. We have mail that is waiting to be sent, and yeah, stuff like that really. There's one kind of slightly confusing one that I came across, which was temp, this var temp. And you might think from the name that wouldn't persist, but it actually does persist. When you reboot the system, this will still be the same. Unlike normal temp, I think the reason for that is that this is really meant for applications to delete and execute and delete in their own time as opposed to the system. But that's one potential bit of confusion. for people. And yeah, actually, why not? Why not? I can, since I'm here, I can show you something. So why not? APT, I installed something recently. So I think if I go into the history log, you can see that. There are a few upgrades. Oh, yes, here we go. I installed the GitHub CLI, and that's here in this log. So if you ever want a list of everything that I've installed previously, you know, go into this log, go into the package manager, and you can see the log. So yeah, I think that's quite cool. And the next one is probably the most confusing. And that's user or Unix system resources. And yeah, I think for the reasons as I described earlier when I was talking about the bin directory, is that really, like, a lot of what's here is mostly sort of very similar to what you can see in other files like bin, sbin, and the lines get a little bit blurry, really. And in fact, it used to be the case that, you know, when I mounted the file system produced, when I ran this RAM disk image, when I was booting up the system, it used to be the case that, you know, bin was required or could be required, and user was not. But that's no longer the case. This image actually mounts user anyway, so it kind of makes bin and sbin redundant. But I guess you can kind of consider it as, you know, a bit legacy. It contains system executables, very similar to bin and sbin. But the key part to remember is that it doesn't contain anything really relevant to the user. That's all in home. It used to have that, which is probably why it's called USR, but it no longer has kind of user-specific files. There's one more big one, mostly because I have Miniconda installed there, and that's called OPT, or optional. This is typically software that is very self-contained. It doesn't spread itself into the bin, the library, or any kind of var file. It doesn't really do that. It just sits. It's very self-contained, like Miniconda, for instance, or the Google Cloud SDK. You can expect that if you download software from a vendor, you can probably expect it to be in here, or at least it's good to have a look at it in here. Oh, sorry, I realize I'm getting close to the final deadline, so I think I'll probably stop here and open up to any questions, if any.
Yeah, I've got one. Thanks, Aaron. Very interesting. So just if you flip back to the dev slide or the devices slide, I think it's slide 9 you've got on the screen there. Would you mind just giving us a bit? I mean, I think you gave us a very concrete example with the differences of the two lists, right? When you plugged in did you plug in a SD card, I think, or did you say USB stick? I'm not sure.
Yeah, like an SD card reader, yeah.
SD card reader. But I mean, can you just give us, I mean, there were a lot of things on that list. And I think you mentioned a couple that, quite frankly, I didn't understand. What other types of things? Are there any really tangible things on that list that we can understand cleanly?
The most tangible thing, I think, to say would be the hard drive. My hard drive is called NVMe, so NVM Express N1. That's just its name. The reason yours might be called SDA, it all depends on the interface that it has with the bus on the motherboard. Mine just happens to be called NVMe. That I think is quite important. And it's very tangible. That is definitely, you know, if I were to split open my computer, I could find the device that corresponds to. Does that answer your question?
Yeah, that's good. And I mean, I'm not trying to catch you out in any way, shape, or form, but I mean, I think that when you plugged in the SD card reader, there was the difference showed 3 different devices had appeared. Were they all related to the SD card reader you added, or were the 2? I think I can't remember what they were. I think you
Quite
said
right. There were 3. There was SDA, SG0, and another one. I think actually, I'm not entirely sure what SG0 is or the other one was, but I can tell you what SDA was. I can. I'm just more familiar with SDA as more sort of referring to kind of a file referring to a hard drive. But yeah, I don't fully understand what the other 2 were, but they were related to that hard drive.
sure, thanks. Any other questions from the floor? No, good. Okay, well, look, Aaron, I will say thank you very much from the team. Very interesting dive into Linux file system. So thank you very much, and we will leave it there.
Okay, thanks everyone.
Thanks, Aaron.
Thanks, Aaron.
Cheers.
Thank you.